Okay, Namaskar, good morning. So today I will discuss on Fourier series today. So if we have a function of if we have fx is a function and fx is periodic and defined in interval, we can have arbitrary interval, say alpha to alpha plus 2l, alpha to alpha plus 2l. Then series representation of fx, that is fx equal to a naught by 2 plus summation an cos n by x by l plus bn sin n by x by l, where n is from 1 to infinity, is called as Fourier series representation of the function fx. Here these a naught, an and bn, these are called as the Fourier coefficients, because the series is in terms of trigonometric series, sine and cosine terms. So this is the Fourier series representation of any function in terms of trigonometric functions. Also, because sine and cosine functions are periodic, therefore function fx is also periodic. So if fx is a periodic function, so this is the must condition for this. So if fx is a periodic function, then fx can be represented as a Fourier series of this type. Now here we have chosen the interval alpha plus 2l. Now this alpha, if it has 3 cases, say if alpha is 0, then this interval become 0 to 2l. Second case, if alpha is minus l, then this interval become minus l, so minus l plus 2l, that is equal to minus l to only l. Okay, so this interval can be minus l to l, it can be 0 to 2l. Also we have the very important case when alpha is 0 and the value of l is pi, then we have this interval 0 to 2 pi. So maximum problems will discuss on 0 to 2 pi, or the fourth case will be alpha is minus pi and l is pi, then this interval become minus pi to pi, or we can take it directly from here. Here these Fourier coefficients a naught, an, and let's discuss a naught first. So here a naught, an, assume the following values, or these are called as, here these Fourier coefficients a naught can be written as 1 upon l, alpha to alpha plus 2l, alpha to alpha plus 2l, fx dx. This coefficient an is 1 upon l, alpha to alpha plus 2l, fx cos of n by x by l dx, and this coefficient bn is 1 upon l, alpha to alpha plus 2l, f of x sine of n by x by l dx. Okay, So these are called as Euler's formula. Euler's formulae to find the Fourier coefficients. Okay, so clearly this A0 is A0, An and Bn. So these are the Fourier coefficients, and these are the formulas given by the famous mathematician Euler's, and by using these formulas we can find out the values of A0, An, Bn. We can substitute these values in this series, or we can give it equation number 1. Okay, and we can substitute the values of A0, An and Bn here, and we can have the Fourier series representation of any function where fx should be periodic. Okay, so in next lecture we will take an example of Fourier series representation of a function, but before that there are some shortcuts that are required that one should know before solving a given problem. Thank you.